Distinguished guests, ladies and gentlemen, before we start commence the program, and here are the following webinar protocol. For each participant ID, please use your real name following with your origin of institution. All of participants are expected to mute only and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you for joining our event today, a researcher and research student enrichment program for hard engineering stream, or we usually call it by RECEP. Before we start our agenda today, I will read out the important information to all attendants. First, please fill the attendance form on the provided link, which will be shared in the Zoom chat room by our committee. The link will be closed in 15 minutes. Second, please fill the feedback form, which will be shared in the Zoom chat room 15 minutes before the session ends, and it will be closed after 1 hour. Third, the attendance and feedback forms are compulsory for these purposes. Attendance is mandatory for the new ITS master and doctoral students. Certificate of participation, which is only eligible for international participants who have 60% attendance or minimum 5 meetings. It is for Stanford, which only eligible for ITS undergraduate students. Participants who wish to ask questions during the Q&A session, please send your question at the provided link in the Zoom chat room, or alternatively, you may raise your hand during the Q&A session to ask your question directly. Bismillahirrahmanirrahim. Welcome to Researcher and Research Student Enrichment Program for Hard Engineering Stream on today, Thursday, 21st October 2021. I'm Dewi from ITS Postgraduate Office, and I will be your Master of Ceremony for this session. Before we start the session, allow me to inform you our today's agenda as follows. For the first agenda is the opening by MC, continued by introduction to the moderator and also the speaker. After that, we will get to the main agenda, the lecture session, then followed by Q&A session, and it will be ended with the conclusion and closing. I would like to remind you again to fill your attendance form shared through the provided link in the Zoom chat room, which will be closed in 15 minutes from now. Before we moving to the next agenda, please allow me to elaborate about today's lecture. Today's lecture theme in RECEP for Hard Engineering Stream is about common research methodology in your field, which will be delivered by our speaker, Dr. Dayang Nurul Fairuz, Abang Zaidel from University Technology Malaysia, and Miss Rizka Desmawati, MSc, from ITS, who will be the one conducting our today's session as our moderator. Let me introduce you to our moderator today. Our moderator today, Ms. Rizka Desmawati, MSc, is graduated from Airlangga University with Bachelor of Science in Biology and from ITS with Master of Science in Biology as well. Currently, she is both lecturer and researcher at the Department of Biology of ITS. Her research interests are in ecology, biogeography, and also product innovation for conservation. So without further ado, let's proceed to the main agenda. To Ms. Rizka Desmawati, our moderator, the time is yours.
Thank you so much, Ms. Dewi Sartika, for such a nice introduction for me. And it has been an honor to me to be a moderator today for this special lecture for RECEP. Today, we call it a very simple with RECEP. And then today we will have a very special guest lecture with the special speaker also, Dr. Dayang Nurul Fairuz Arbang Zaidel from the University Technology Malaysia. Hello, Ibu.
Hello, Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. It's been such an honor to meet you today.
Yes, me too.
Thank you so much. So before we started this lecture, I would love to introduce all of you to our speakers today. And for Dr. Dayang, the educational background will be from PhD in Bioprocess Engineering from the Technical University of Denmark, and also Master of Science in Food Engineering from the University Putra Malaysia. And her also get the Bachelor of Engineering in Chemical Engineering from the University of Manchester Institute of Science and Technology. And Dr. Dayang also have academic and a lot of professional experience, such as now Associate Professor at the Department of Bioprocess and Polymer Engineering in the University Technology Malaysia, and also member of Malaysian Institute of Food Technology, and member of Asia Pacific Chemical, Biological, and Environmental Engineering Society. And we know that maybe a lot of research interest from Dr. Dayang, but for the main topic will be food processing and technology, enzyme technology, and excuse me, I can read it, and food. So before we started, Dr. Dayang, maybe the time is yours for maybe 1 hour more to get a lecture, and also after that we will have a Q&A session. However, if you're willing to have such nice like a discussion between a lecture, we can do it also. So I think this is the time is yours, Dr. Dayang. Thank you. Welcome.
Okay, thank you very much, Ms. Rizka Desmawati. Such a very nice introduction. Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good evening to all the participants. Okay, I can see that we have almost like 155 participants.
Yes,
so
yes.
It's such
been a lot.
Nice, yes, a nice number. Okay, and before I start, I would like to thank ITS for this such a nice event program, a researcher and research student enrichment program. Okay, I'm very honored to be invited today to have this sharing session. I will say that it's a sharing, more to sharing, to all of you what we have, what I can say that by some of our experience, we can share later on, we can discuss. Okay, if you have any question, you can probably write it in the chat box, is it? Yeah, and also if you have a question, just raise your hand, yeah? So I will share my screen now. Okay, I hope you can see my screen.
Yes.
My slide here.
Okay, great.
Okay, so the topic that has been given to me is common research methodology in your field for hard engineering stream. Okay, as introduced by Ms. Iska, my name is Dayang. Okay, I'm from University Technology Malaysia, which also known as UTM. Okay, so I don't want to go into detail for this a little bit about myself, but as introduced by Ms. Iska just now, I'm from UTM, from the School of Chemical and Energy Engineering, yeah, UTM. So most probably what I will talk about today is a general research methodology. I have been informed that many of you are from various engineering background. So it's not only chemical engineering. So probably there are mechanical, civil, electrical, and etc. So I will try to make it as general as possible so that all of you can understand and follow what I will share today. Yeah. All right. Mostly my research area is food processing and technology, enzyme technology, and also green technology extractions. So probably some examples I will give mostly some related to my research. Yeah. Okay. Before I go further, this is our campus, located in Johor Bahru, which is a southern part of Peninsular Malaysia. Okay, I'm not sure if you have been to Johor Bahru, but if after this COVID-19 is, have been settled, the cases is reduced, probably you may go to our campus one day. Probably to have like exchange student. Yeah, we also have that exchange student program in UTM. Okay, okay. This is our beautiful campus featuring the mosque in the middle of our campus. Okay, and this is our Kuala Lumpur campus located in the city center. It is also a beautiful campus, but it's quite small. Compared to our Johor Bahru campus, the main campus. Yeah. So for my faculty, it is in Johor Bahru, okay, which is the biggest faculty of engineering. Okay. So this is we have like 7 faculties mainly. Okay. The faculty of engineering is the biggest one, in which we have 6 schools. Consists of School of Chemical Engineering, School of Electrical Engineering, Civil Engineering, Mechanical Engineering, Biomedical, and Health Science, and also School of Computing. And we also have other faculties in UTMKL. Yeah. All right. So that's all a brief introduction about UTM. So I hope that after this we have more collaboration. Yeah. All right. So. Okay, so this is the presentation outline for today. All right, so I will give some introduction to research methodology, the research process, okay, and experimental methods and planning, yeah, and understanding types of variables, data analysis, and conclusion. Okay. So first of all, before we start to the research methodology, of course, as a research student, what you have to know is the basic. First of all, you have to know what is research and why you want to do research. Yeah, and research is what I can say is that it's a systematic investigation into the study of materials and sources in order to establish facts and reach new conclusions. Of course, there are a lot of other definitions, Okay, but one of the definition I can give is that this definition, probably you have other definition of your own. Okay, why you want to do research, and of course you have to know, okay, why you want to do research and what is the topic that you are interested in before you start your research methodology. Okay, the first thing that you must know, okay, before you start your research. Yeah. Okay, this is the steps, okay, in the research process. Okay, first of all, the most important thing that for research is that you must identify what is the main problem or the real problem that you want to solve. Okay, because some we understand that some of the students, they do not know what is the actual problem that they want to solve. Sometimes they said, okay, probably my supervisor asked me to do it, right? So sometimes we can ask, what is it that you want to solve? Oh, I want to solve environmental problem. So it's very, very general, because for research, you must know the research gap, the gap that you want to close in your area, in your field. Because, for example, in chemical engineering, for our field in chemical engineering, let's say for the environmental engineering, that you want to solve environmental problem. Probably in the environmental problem, what is it that the specific problem that you want to solve? Probably for the environmental, you want to solve for the usage of solvent during the extraction of your active compound. So what is the real problem in that area? Why do you want to solve that problem with the usage of solvent in the extraction? So you have to really dig in to identify the problem first, before you start any of your research methodology and everything. Before you can start, you must identify this. Yeah, so then you can formulate your research questions from the problem that you identify. Yeah, so that is the research gap. So from that, you review the literature. Okay, when you review literature, as you read along the journals, the articles, then you can collect. You can collect the previous studies that have been carried out by other researchers in the same area as yours. Okay, probably what you want to solve, other people or other researchers have been doing it for quite some time. And sometimes as you go along, you can see that what you want to solve is not really a novelty. You sometimes you will encounter something like that. Some students, after 1 year, 2 years of the research, they have found that, oh, some people have published what they want to do, what they are planning to do, right? So that's why you have to continuously doing this literature review, not only during your first year of your study, but continuously along the study, from your first year until your final year. Even during your final year, you have to update. You have to update continuously the literature. Sometimes during your first year, the literature that you are reading, that you have read, may be it's not valid anymore. Maybe probably along the way, during your third year or fourth year, someone else have been publishing or reporting the same thing that you are doing. So that's why it's very important for you to continuously doing the review, literature review. Yeah. Okay. And also, when you do your literature review, this is where you are also collecting the methodology, the methods that you need to use in your research, in your own study. Okay, because in every methodology that you are going to use, you need to refer. You need to refer to other researchers' work. You cannot just simply, okay, I want to use this method because I think this is the best method. But this method is not being reported anywhere else. Yeah, you just simply invent it yourself. Yeah. So how would we verify that your method is valid? So that's why it's important for you to get the literature and refer the methods that has been used by previous study. Okay. Right. Then you can formulate hypotheses. Okay. What is it that you want to solve? From this hypothesis, you can expect what is it that you will achieve. Okay. Okay. After that, you can construct your research design. Okay. What is it that the methods that you will use? Okay. What kind of statistical analysis that you will use? Yeah? Okay, then after that, after you have reached or you have plan or construct your research design, then you start your collection, data collection, experimental experiment work. Yeah. Then after you have collect all the data, then you analyze. Okay, analyze your data. Then interpretation of the results, meaning that you can have your result presentation and discussion. Okay. And at the end, you will write the research report, meaning either your thesis or your dissertation or your journal articles. Okay. So along the way, probably you have different objectives. Probably along the way, first year or second year, you want to publish a paper, journal articles. Yeah. And usually for thesis is the ultimate goal of a research student, right? Okay. And during after that, you may present your result during the viva voce. Okay, your defense. Okay. So this is basically the steps in a research process for a research student. Okay. 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 So this is also the flow for which for a research design and methodology. Usually, the research question or the problem statement will drive all the other parts of the research plan. That's why it's very important for you to know what is actually the problem that you want to solve. Then after that, you know what you can plan. After you know the problem that you want to solve, then you can plan for other parts of the research process. Okay. So first of all, after you know the problem statement or the research question has been formulated, okay, then you can design your experiment so that you can, from the design experiment, you can achieve the outcome. Yeah. Then the data collection, data analysis, data interpretation, and up to the result and data presentation. Okay. Okay. So this is research design and methodology. Yeah. So the design is actually a plan. Is what you want to plan for your research. Okay. Before you can start any of your experiment, you cannot just simply go to the lab and start your experiment. It will be a disaster because you must have a plan first. Anything that you want to do, you must have a plan. What type of, for example, what equipment that you want to use, how long is or how many runs you will have for your one of your experiment, and what is the result that you want. Yeah? What is the parameters or variables that you will study for your experiment. So that's why you need to plan first. Okay, plan. This is where you need to discuss with your supervisor. Okay, usually the supervisor will help to plan. First of all, of course, you need to know yourself. You plan ahead before you see your supervisor. Okay. Then you go and see your supervisor. Okay, Prof, this is my plan for this experiment. I would do it like this. This is what I will study. I will vary the temperature, pressure, something like that, yeah, and achieve the result of what the strength of the material, for example, yeah. So that's why design is a plan or a structured framework of how you intend to conduct your research, okay, before you can start any of your experiment. And the master plan specifying the methods and procedures for collecting and analyzing the info. So what is the method that you want to use? Either you are going to follow or refer to this method from this author from the previous study, or you have a standard method that you want to follow. Okay, so you have to know specifically what is it the thing that you will use in your research methodology. Yeah? Okay. Then it's also a strategic framework for action that serves as a bridge between research questions and the execution, okay, or the implementation of the research. So meaning that you have the problem statement or the research question that you want to solve, okay, and you want to do it. You want to do your research to solve this research question that you want to do. So the design is something that to connect between your research questions and the execution or implementation of your research. So before you can do anything, the plan or the design is the one that will bring you from your research questions to your implementation of your research experiment. Okay, so then that is the design. Then the methodology refers to the methods, techniques, and procedures that are employed in implementing your research plan. So you have the design already, but inside the design, what is the methodology that you are going to use? What are the techniques and procedures? Yeah. Okay. Okay. So this is one example, a very simple one. Yeah. Let's say it's a what we call it, ideology or something. So let's read the story below. Okay, can you cook? Yeah. What is the connection between cooking with research? Okay, so as you can see, we read together. Okay, I am a terrible cook. Okay, when you are a terrible cook, of course you need a recipe, right? Okay, one day I asked my mother for a recipe for a lasagna. Okay, if you know what is lasagna, yeah, it's not something that is very difficult, but it's also not something very simple. So you need some guide to make it, for example. Yeah. Okay, I followed every single step she said, and in the end, what I had was so far from it. In that, I was even embarrassed to call it a lasagna. I don't know what what it looks like. Okay, the white sauce was not thick enough. Okay, the meat was raw, and overall of it got a bit burnt. So dah lah, apa tu, dia punya sauce is dah not thick, and then the meat raw, okay, and burnt lah tu. Okay, so at the end, I ordered a burger with fries. Okay, so as you can see, the logic of a recipe is that if you follow every single step, you should be able to reproduce exactly every time, okay, and make a great meal. But it does not work exactly like that. So in science, the recipe is our methodology chapter. Okay, so meaning that in methodology, you should have step by step what is the step in every single thing that you do. Okay, and the logic is it should describe how your study or experimental work was done, okay, step by step, to the point that anyone else would be able to replicate your work. So meaning after you have done your master or PhD, after 2 or 3 years of your study, you have published in your journal or published in your thesis. After like 2-3 years or 5 years, your junior comes and they want to do exactly like what you did, probably with a different material or a different angle a bit, but they want to use your method. But suddenly what they can see is that it's not very clear step, then they cannot repeat your work, kan? So it's a bit unfortunate lah, unfortunate or kind of poor to the other people, so that because they cannot refer to your method. So it should be like whatever that you do must be reported in the methodology. Okay, even the equipment, the model of the equipment, the materials that you use, where did you buy your materials, what purity of chemicals that you use. So up to the details of every single thing. Okay, even let's say if you say that you are drying the materials, at what temperature did you dry? Okay, for example, this lasagna. Okay, probably her mother said, okay, you can heat your lasagna in the oven. Okay, but her mother did not say what is the temperature that you should use, or probably her mother has a different model of oven than me. Okay, then my mother have a different oven, different model, so that the temperature is different. So that's why the lasagna get burned, right? So that's why it's important for us to report the model that you use and the temperature and every single condition, because other people who want to repeat your methods, probably they have a different types of equipment, but they want to use the same method. So they might have to modify a little bit your methods to suit their conditions. Yeah? Okay, because other people might not have to buy the same model as yours, but they can modify the methods so that they can also achieve the same results as yours. Yeah? Okay. So why is the methodology important? Okay, that's what I have said just now. Okay, it is important because it shows the recipe you followed during the development of your research. So it's some kind of like a recipe, step by step, even the ingredient and everything that you use. Okay, so remember, in case you use any inaccurate or a weak methodology, everything else in your thesis, including your results, conclusions, or recommendations, can be wrong. Okay, right? Then why? Because it is irrelevant that you had an incredible research question, but you measure things incorrectly, then the data collected will be incorrect. Then if you did not apply the suitable method and choose the right sample, every result will be inaccurate. So you can see the effect. Even though that you have the most incredible or the most interesting research topic, interesting research question, but then you have chosen your methods incorrectly, it will give impact to your result. Yeah. Okay, and you will have findings, but they will have very little validity. But probably if it's not it's inaccurate, and also it has the validity will be questioned. Yeah. Okay. Yes, these are the objectives of research methodology. Some of it is to introduce the overall approach that you use to indicate how the approach fits the overall research design, to describe the specific methods of your data collection, okay, to explain how you intend to analyze and interpret your result. For example, what statistical analysis that you're using, theoretical framework that you're using, okay, to provide background and rationale for unfamiliar methodologies if necessary, and also to address potential limitations. Sometimes you have limitation in your institute, right? So you have to specify in the methodology. So this is also to provide answers, okay? Of course, you have the research questions, so you want answer, right? So you have to get the answer for your research question, and it is to answer these two main questions. How was the data collected? So the research methodology is to how did you collect this? How are you going to collect your data? Okay, what is the method used, materials used, equipment, analysis? And the second one is how was the data analyzed? Of course, after you get all the data, maybe probably 1,000 data, how did you analyze this? And how will you present your data? What type of graph that you will use? How would you present your data to make it sound like it has some impact or significant importance in your results? Okay, this is some element or some key for high quality research. Okay, so it is one of it is to have a reference from previous work. Of course, there are also standard methods that you can refer to. Okay, so must all the methodology must have reference. Yeah. Okay, then it can be replicated or it is reproducible. Okay, if other people would like to follow your methods, then they can reproduce it, yeah, using your method, and you can generalize to other settings. For example, if other people would like to follow your method, they can modify to suit their settings. Yeah. So it is based on some logical rationale and tied to a theory. So you must have a theory behind it. Why you are doing the research? Yeah, that's why the literature review is important. It's doable. Others can refer to your methods. Okay, and it is an activity that should be undertaken purely for the betterment of living beings. Of course, you want to do research. You want to improve some methods or improve some materials or provide a better solution to the industry, for example. Okay, so it is a betterment of living beings. Okay, so these are some scientific methods. Okay, of course, these are some of the methods that are used in research, analysis, hypothesis, synthesis, and validation. Okay, analysis means that you will investigate or also describe the data that you obtain. Okay, hypothesis, you have to set your goals, specify your solution. Meaning that you can what is the expectation from your research. Synthesis, the design of experiment, the conduct of the experiment. Then at the end, you validate your data and draw a conclusion. Okay. This hypothesis should be at the beginning. It should not be here. It should be at the beginning, before your research methodology. But basically, it's something that you have to. It's an idea to give you an idea what can be tested through investigation, and also what is your prediction of what outcomes will occur at the end of your study. Yeah. Okay. So the hypothesis also will define the scope of field of your study. what you want, what is actually that you want to study. Okay, then what is the possible solution? That is your hypothesis. Yeah, it is to help the researcher with a good plan. Okay, the plan to approach the problem. So you know that this is the problem, and you know this would be a good solution, so that you can achieve this outcome. So this is what a hypothesis is. Yeah. Okay. All right. So far, is there any question, Miss Siska?
Yes, Ibu. Today, in the chat book, the participant didn't ask from the chat book. However, I would love to check from the link that maybe for the committee share. And yes, we have one questions. Is that okay to answer right now?
Yeah, one question probably.
Okay. Yes. From Muhammad Nufratama. Yeah. From the ITS also. So the questions will be how to develop the ideas into writing. How to develop the ideas. I think this is also the problem for me because the ideas.
Yes,
This is the first type, right? Yes. Maybe if Dr. Dayang willing to answer right now.
Okay, I understand.
Okay, great.
Because
Thank you.
Sometimes we have a lot of idea, right? We have always thinking, okay, what if I do it like this, and what if I do it like that, and then we keep reading and get some more idea, right?
Yes.
It's
a lot of ideas.
never ending. It's a never ending.
Yes, never ending to think about that.
When we read the journal, it keeps coming. The idea keeps coming, and then after sometimes you need to make it you must make a plan, because you will not reach a perfect meaning a perfect research idea, because sometimes when you read a lot of journals, articles, you will be more confused. I understand that because I have been there. Because writing is also a difficult task. It's very difficult actually. I understand because some people they are good in sharing their idea, but
yes,
when it comes to writing, it will be very, very difficult, right?
yes,
because writing a technical thesis or a journal, it takes a lot of mean that you must know what is the thing that is important, okay, and you have to refer a lot to previous thesis, okay, because you cannot just simply write everything, because then your thesis will be like 200 or 300 pages. It will be a lot. So that's why it's very important for you to identify the research gap. That's why the research gap is important. What is actually that you want to solve? Because of course, in different fields that of the engineering, they have different types of problem, right? But it can be one specific problem that you want to solve. Don't try to solve the world problem. The world problem, like I would like to solve the problem with hunger, people without food.
Yeah,
that's a very general problem, right? So that you will have so many ideas, but then just focus. Okay, how do you want to help this hunger? Okay, inside the hunger problem, what is the tiny things in that particular problem? Probably you want to solve the problem among the children only. So you make the limitation. You have to make a limitation to your scope of study. That's why it's important in a research process. You know, you have to limit. You make a limit to your research scope. The scope of study is very important because you may want to solve the world problem, but it's impossible. So that's why you have to limit. Okay, I want to focus on the children. Okay, children also a lot, right? Children, it can be like from baby or until 12 years old. But you limit. Okay, for the children problem, I would like to solve only the children between 5 to 7 years old, for example. Okay, what is the problem that you want to solve between these 5 to 7 years old? I would like to focus on the malnutrition deficiency in the children among between 5 to 7 years old. Okay, what is it that you want to solve? The malnutrition problem, but then what is the solution that you want to provide to solve this problem? Probably you can say that I would like to design or formulate a food that can be provided to the children between 5 to 7 years old. Okay, what is the food that you want to provide? Then after that, you have to make it like step by step. The scope of study that you have to limit again and limit until you have reached your solution, so that your idea becomes narrow and focus. Focus. You have to the meaning that you have a big idea, but you have to focus, limit your idea until you reach the a very specific and focused scope. Yeah, so that you won't have a problem in writing. When you have a specific scope, then you can limit your what's this? Also for the literature, you can just search for that particular keyword. So in your research, you must have keyword. Okay, at least 5 keywords. So within your literature review as well, you must have keywords for you to write your literature. Okay, so that you won't have to include everything under the sun into your literature, right? So you can start writing with bullet points first, yeah, with the keywords that you have, then develop it from the keywords. Okay, I think
yes. I think for now we have questions from Bapak Muhammad Nufratama and already answer, and maybe
I will
Dr. Dayang can continue again. Okay.
Okay.
Maybe the next will be a lot of questions, because this is a very great about methodology, will be a very key point to our research also, right?
Yes.
Dr. Dayang. Yes, great.
Yes, it's very important. Okay. All right, so I will continue. Okay, so how to start your research design? Yeah? So first of all, of course, as I said, you must know the type of research that you are going to do. Usually for engineering field, we have mostly experiments. If I'm not mistaken, yeah, we rarely use questionnaire. Okay, a questionnaire is usually for the social science. Okay, case study also not very common, but I'm not sure for other engineering. But in chemical engineering, we rarely use case study. Or probably if you are in science, probably you use case study or comparison. Okay. So you have to then after you know your research, then you identify the variables. I will explain further the different types of variables that we can use in the research. Yeah. Then operational definitions of the variables. Okay, what is the range? Range of the variables that you're going to use for your study. So for this range also you need to read a lot. Okay, read a lot from literature. Usually some literature or some journals, they have done probably the same or similar work as yours, and they have reported the range of parameters or variables that they have been using that have achieved optimum outcomes. So you can use that journals or the reported range of the parameters so that you don't have to repeat again and redo again everything from the scratch, right? You don't have to. You don't have to do that. You can refer to the literature or the reported range of the parameters that have been used by other people. Yeah. Okay, so in your method later on you can justify. Okay, that's why it's important for you to have the reference. Okay, for example, in your study you want to use this range of temperature. Okay, range of temperature for your study. Then you have to cite which journal paper that has been using the same range as yours. So you don't have to redo again everything to justify why you choose this, or you don't have to do preliminary study, a lot of preliminary study, right? So you can have that reference for your study as a start. Yeah? Okay, and then after you get your data collection, then you analyze your data, then you select your design for data analysis, your statistical analysis. The design for data analysis, meaning that some of you might want to just to study the effect of two parameters or two variables to achieve one outcome or one response. But some of you probably would like to study the effect of three of variables or parameters on two or three responses of your study. Example, the effect of temperature and pressure on material, the strength of material, or the morphological of a material, or the color, example. So and the other factors, temperature, pressure, or something like different types of fillings, for example. So you have a lot of variables that you want to study. So some of you would like to optimize. So optimization of your process, for example. So there are a lot of different design of analysis that you can use. Okay. Some of you would use one factor at a time. One factor at a time meaning that one factor that you will vary, and the rest you fix. Then you can get your result. Then after that you vary another factor, yeah, and fix another factor, for example. Okay. So I will explain in detail after this. Okay. So these are the different types of research. Some of it are for social science, and mostly for, and also some of it are from for management or also business students. But what usually for engineering students that I know of, usually we are using experiment, okay, experimental, and also I'm not sure what for other engineering, but usually we have experiment, yeah, either in the lab or in the field. Okay. Okay. All right. For experimental methods, okay, it's usually it's a project dependent. Okay. Why is a project dependent? Because we cannot generalize the method. It's very specific. For civil engineering student, research, it will be they have a specific method that they can refer to, like mechanical engineering. They have specific method that they can refer to, yeah, in their field. And chemical engineering as well, we have a method depending on the project, because in chemical engineering as well we have different type of research area. We have safety, we have bioprocess, we have polymer engineering, we have environmental. So there are different types of project research. So you cannot generalize the method. You have to specify what kind of method that you're using, okay, and must be specific according to the method to the project need. And method from previous study can be modified to suit your project, because sometimes the previous methods from the published journal, okay, they are using different materials, so you can use the method, okay, but you can modify, okay. Probably the equipment that they are using have a different setting, okay. They have a different let's say pressure setting. You have the range of your pressure setting is probably like 0 to 10 Pascal or something like that, but they have 0 to 5, so that you can modify according that suits your project. What is the aim that you want to achieve? Yeah? And probably your oven or your equipment is smaller, that the volume is smaller, like the example rheological testing, the cup is smaller, so you can modify according to your project, okay. Okay, then the accuracy and precision must use rigorous design of carefully controlled and documented experiments aimed at accuracy and precision. Accuracy and precision is important as well, because then especially when you do your experiment, you must have at least duplicate your data, yeah, so that when you present your data with such accuracy, a very small standard deviation, you have a very small standard deviation, so people will be more it's like your result will be more valid, when people see your result, it's more valid, because the accuracy, the standard deviation is very small, for example, okay. For example, if you have what result that is that has a very high standard deviation or standard error, how would people see when you do this kind of method, but you have a result that is very far apart? One time you do it, probably you have like you have what is this your yield of your extract, for example. One time you run your experiment, your yield is 10%. Okay, the oil, for example, the yield of oil that you extract, 10%. The second time you run, the yield of oil is 50%. Okay, then the range of the standard deviation is very far apart. So it's when people see that it's not, they are not convinced of your methods, meaning that your method can it be trusted? Can you use that method actually to run, because your standard deviation is very far, right? So that's why it's important to have accuracy in your methods, okay? So that every time you repeat again and again and again, you have the same result. Okay. Then for standard methods, usually you have standard methods by British standards or STM, so that when possible you can use the standard methods. Okay. Of course, for documentation, you must document all your results, even though the result there is a junk result or rubbish, you know. Sometimes, you know, after 1 month or 2 months running the experiment, it's all cannot be used.
Yes.
Cannot be used.
Sometimes
then
it happens.
Very frustrated. You're very frustrated, right? After 1 month, 2 months running the experiment, suddenly you say that, why is the result like this? It cannot be used at all. but please don't throw it away in the dustbin, in the garbage. keep it, just keep it. You never know if suddenly it can be, some kind of useful some other later day, yeah. Okay, you will never know when you will need them. Okay, all right, just save it, and of course keep your data updated in somewhere safe. Okay, probably in Google Drive, yeah, online punya cloud system, because it happens all the time that the students they have a problem with this data apa ni, just in the laptop, when suddenly the laptop is having a technical problem, so that's why it's very important for you to back up your data in a cloud system. Okay, all right. Okay, this is a planning. Okay, planning of your experiment. Usually for my student, I will advise them to make a flow chart of research activities. Yeah, so it can be either you divide it into step by step. For example, like this. This is a catalyst, a kinetic study. Okay, of a catalyst. So first, we will start with catalyst preparation, meaning that this is a sample preparation. Catalyst preparation, then the sample characterization. So in each of the steps, you must identify what is the method that you will use. For example, for the preparation, you will use washing, drying, and then the characterization, you will analyze it using XRD, TM, FISM, etc. Then after that, what will be done? And then you will have the reaction performance, and then you will have the catalyst recovery, characterization, and product analysis until kinetic study. So in each of these steps, you must identify what are the general idea that you want to do. Sometimes you also can specify the range of the parameters that you will use in each of the steps. Okay. Okay. Also, the flow chart also can be divided according to your objectives or scope of study. For example, for phase 1 is to achieve objective number 1. Okay. Phase number 2 is to achieve objective number 2, and then phase number 3 is to achieve objective number 3. So it's like a planning of your experiment. First, what will you do? The second, after you achieve this objective number 1, then you start the second phase. So after you achieve the phase number 2, then you move to the next phase. So you can see clearly what is it that you will achieve. Yeah. Okay. Okay, then you can use Gantt chart to plan your activities. It's either monthly or yearly. Okay, it's also important for you to indicate milestone achievement, the red dot over there. Okay, usually this is for PhD lah. PhD is a 3-year study. Okay, when you should start your experiment. Okay, for example, after half year of year 1, you must start your experiment, so that you will not be like lagging behind. Meaning when you refer to the Gantt chart, you know that okay, I'm a bit slow. In year 1, I should start my experiment in June, for example, but now it's already October. So what should I do now? And I haven't prepared or buy any material yet. So that's why this Gantt chart is some kind of giving you some overall view to how you should to where is your research activity. Yeah? Okay. Then we move to what should be included in research methodology. Is somehow is this is the general content. General content. Usually, it will start with the description of your materials, okay, what is the material that you use, okay, procedure, calculations, equations, techniques, procedure, equipments, and calibration plots that you will use, okay. This is the very common one, okay. Then when you are developing your experiment, you have to it is important to detail out the instruments or equipments that you use in your study, which include the model and which country that manufacture this equipment, so that when other people following your methods, they know that they are using you are using what model in what country and from which country, so that if they have different model, they will know probably they have this this is the reason why they don't have the same result as yours, okay. Then description of your analytical methods, including the reference, the limitations, and also then explanation of what you did and how you did it, then to evaluate the reliability and validity of the research, okay. These are the general content in your research methodology. Okay, these are some example I can give, but this is from my students, okay, from my student. You can see on the right hand side is the flow chart. That's why if I said just now, flow chart, usually I will ask my students to do flow chart so that you will know what are the steps that will be conducted in your study, and also at the step by step the variables, the range of the variables, and the analysis that you will conduct, okay, so that you have the idea. These are the scope of study that you will conduct in your study in your research. This is example of the materials and also sample preparation. Okay, you can see there are some equations and also the research design, experimental design. This one, my student, she's using RSM for optimization. So she has 3 variables, which are the time, solvent solid ratio, and also power of the microwave. So she used this experimental design to run her experiment. So then you can follow the number of run to start your experiment. What is the response that she collect from the research? So for example, the yield, the oil yield. So you have to focus. What is it that the outcome that you wish for? Yeah. This example also for the research design, okay, with the equation, and also from you can see that all the methods have reference. Yeah. This is also another example, number 2. Also have some flow chart, the materials. This one, she listed all the chemicals used and also the methods used, who's the supplier. Okay, you can be as detailed as this, yeah, if you wish for, but also depends. You can discuss with your supervisor how to present your methodology. Yeah. This one, how is the diagram? Sometimes it's also helpful to have a diagram to illustrate your method. It's probably you have a new method developed from your study. It's very useful to have an illustration. Yeah. Also flowchart for fabrication. Okay, so that's all for the example. Okay. So now we go for the understanding of types of variables. Okay, when you have you know your the types of research that you want to do. Okay, then you set the variables. Okay, the variables that you want to study. Yeah. Variables is a target measurement or outcome of your problem statement or research question. That variables are the things that you measure or collecting data or forming groups in order to conduct your research study and answer the question. So it's important to be able to identify the key variables within your problem statement, because when you have your problem statement, then you focus up to the scope of your study. You have limit the scope of study. Then you identify what is the significant variables that will affect your result. Okay. Okay, these are the different types of variables. Okay. Okay, the first one is the independent variable. Independent variable is the one condition that you change, okay, that you change in the experiment. Okay, and while the dependent variable is the one that is the variable that you measure or observe. Okay, the dependent variable gets its name because it is a factor that is dependent on the state of the independent variable. Okay, I hope that you understand. Okay, when you change the independent variable, it will affect the dependent variable. So for example, if you change the effect, for example, if you change, you want to study the effect of temperature, okay, on solubility, then the temperature is your independent variable, and meaning that the solubility will be your dependent variable. So meaning the solubility will be depending on the change in the temperature. Okay. Then one more is the control variable. Control variable is that the one that you will fix, you will not change, because sometimes there are other factors that will affect the outcome. For example, you want to study the effect of temperature on solubility. The control variable could be the source of water used in the experiment, the size and type of containers used, okay, to mix the chemicals, and the amount of mixing time. So you only want to study the effect of temperature. You don't want to study any other things, okay, because they are, if you change the mixing time, it will also affect the solubility, but you do not want to study that. You only want to study the temperature. So you fix the other variable. Okay, you fix the other parameter so that you only study on the temperature effect on the solubility. So these are the three types of variables. One is independent, the second one is dependent, and the third one is control variables. Ms. Iska, if I'm late or something more than my time, please let me know.
Actually, I already see from the question form that we already have more 3 questions.
Okay.
However, if Dr. Dayang want to continue first for the presentation, I think we still have 5 minutes to go to your presentation, and after that we will continue with our discussion.
Okay,
it will
that's
be
better.
great.
Yeah, that's better.
Great.
Okay,
Yes.
okay.
Thank you.
All right. Okay, so after you have these 3 types of variables, how to decide which variables are significantly important for your study? So this is when your literature review comes in. So because literature review is important, because that is where other researchers have reported on probably the similar research like what you are doing. So you can read from the literature. Okay, this researcher has reported that temperature is the most significant, but not the mixing time. So I can fix the mixing time. Okay, this researcher has reported that the size of container is not significant. I can fix that. But the other researcher has reported that the source of water, the different types of water, or the density of the water, for example, is affecting significance. So I will use that as independent variable, for example. So you can use literature review as your starting point of your to decide the variables. Okay. Okay, this is one example, very simple one. Okay, very simple one. This is effect of fertilizer on plant growth. Okay, so you can see that ABC is using fertilizer A, fertilizer B, fertilizer C. So the independent variable will be the different types of fertilizer. So, and then the dependent variable is the growth of the height of the plant. Okay, and the control variable is the size of the pot. You use the same size of pot. You use the same amount of fertilizer, and you also use the same amount of sunlight that the plant gets. So you control everything else except for the different types of fertilizer. Okay. This is the 5 key components of the data analysis plan. Okay, for after you get your result, then you can start your data analysis. Okay. Okay, this is okay. Usually, for our engineering, we have quantitative data. Okay, because usually we do not use qualitative. It's for social science. Yeah. We have measurable, and also usually we have numbers for our data. Okay. Then for quantitative, there are two different types. For example, continuous data and discrete data. Okay, usually for continuous data, it can be placed on a measurement scale. For example, centimeter in length in centimeter, or temperature in degrees Celsius. For discrete data, is a number that cannot be in a point form. It must be in a numerical values. For example, number of person, number of visits per day. Yeah? Okay. Then approach of statistical analysis. Usually after you obtain your result, you must have some kind of statistical analysis. Yeah, is to summarize your data in a shorter form, to understand the process and possible prediction based on the understanding, to evaluate the credibility of your result. Okay, there is no rule which approach is better to another, but it depends on your argument and justification, and also depends on your set of data. Okay, for example, there are analysis of variance. Okay, ANOVA, usually we call it ANOVA. And there are t-test, f-test, and also you can use response surface methodology for optimization. So there are a lot of different types of statistical analysis. Okay, approach to these three types, I will explain briefly. Okay, the different types. When for ANOVA, you can use ANOVA when your results or methods are compared where more than one factor can be of influence and must be distinguished from random effects, meaning that if you have like two or three, more than three factors that you are studying that can influence your result, you can use ANOVA. Okay, then for f-test, Fisher test, okay, it's a comparison of the spread of two sets of data to test if the sets belong to the same population. So meaning that before you do the t-test, you must perform f-test first to determine what type of t-test that you can do, because t-test has different types as well. Okay, where the t-test, different types of t-tests can be used depending on the set of data. There are student t-tests, paired t-tests, Cochrane t-tests. So you can search for these different types. It depends on also your set of data, because different set of data they use different type of t-tests. But if you have more than two set of data, you can use ANOVA. ANOVA will be more suitable for three or two or three more. Okay, these are some common statistical tools. Okay, for engineering fields, the most common one, or most not common lah, not the simple one is Microsoft Excel. because Microsoft Excel has a statistical analysis tool, okay, where you can you can analyze the t-test, you can analyze the ANOVA using Microsoft Excel. It's a very simple one, the basic one. But others you can use if you know some coding, the software coding, where you can also find the statistical. You can do the statistical analysis using other software. Yeah. The most I think popular one for social science is SPSS and SAS, if I'm not mistaken. But if, for example, the MATLAB, SPSS, you must know some probably simple coding, just to get the result of the statistical analysis. Yeah. These are some data presentation. Of course, if you have duplicate data, you must get the mean. Mean meaning the average of your data. Okay, if you have you have a triplicate, you can get the mean. And usually standard deviation you must calculate for your data. Yeah? Okay, to show that your data is accurate or it can be reproduced. Yeah? This is response surface methodology is one type of mathematical and statistical method for modeling and analyzing a process. Usually, if you have more than 2 variables, then you can use RSM, and it's usually for optimization, okay, to improve the performance of a system, a process, or a product, in which you want to achieve some optimum or maximum benefit from it. Okay, usually, if you want to use RSM, you better start using this software or from the beginning of your design. Yeah? For example, you can use Design Expert. Okay, you can use Minitab. There's one more, I think, Statistica software. So there are a lot of different types of software that you can use for RSM. Okay. So these are just other considerations for your research methodology. Be realistic. Don't, you want to study 10 factors, right? So how many years you will complete your study? I'm not sure. If you want to study to 10 factors, then be precise. Be flexible. Sometimes you need to modify your method because after probably 3 times, or you have repeat the experiment for how many times, then you have to be flexible and modify your methods to make sure that you can achieve what you wish for. Yeah, right. Then test your methods in advance, and then consider revising your research question. Consider revising your methods, just as I said. Then conclusion, these decisions affect the conclusions. Okay, your design and methodology affects your conclusions, and hence careful consideration prior to your study. And you want your research to be valid, okay, and truth, rational, and objective. So it must be it has a validity when it has the capacity of what it aims to your study. Then different types of research design have different threats to validity. So it depends also on your field. So different field might have different approach. Okay, then lastly from me, stay safe and healthy during this COVID-19. So I hope that all of us can take care of ourselves. So avoid crowded places lah. Okay.
Yes.
So that's all from me, Miss Iska.
Yes, thank you so much, Dr. Dayang. And also we have questions from the question form. And the first maybe from Ibu Sari Ayu Wulandari from ITS also. And for the questions will be how to make an idea with the novelty. And what the difference between arranging novelty on the research I'm so sorry. Wait, on the research, a proposal, and arranging novelty on a research article. So maybe for the first question will be how to make an idea with the novelty.
Okay.
And the second one will be, is there any difference between arranging novelty on the research proposal and then research article or something like journal? Yes.
Okay. So the first question, how to arrange idea into novelty?
Yes. Yes.
Right? Okay. Yes, novelty is very, very important, especially for PhD, right? PhD, when you don't have a novelty, then it will be, you will have a trouble during especially during your defense later on. Even during your proposal stage, even during your proposal stage, the examiner will ask, what is your novelty? What is it that you want to achieve in your study, right? That is the first one. Usually, that is the first question by the examiner. If you fail to answer this, then idea is an idea.
Yes.
A lot of idea, right? So what? So what? Right? So how do you make sure that your idea is a novel idea? Okay, that's why I keep saying that you have to read a lot. When you read a lot, when you read a journal a lot, you will find if you have a specific idea for your study, but you must know if your idea have been published or not. Have your idea been published? Has anyone been doing the same thing as what you are doing? Okay, so you have to focus. You have a general idea. Okay, general idea meaning that what is it that you want to what topic that you want to cover, but in that topic you must be specific. Okay, specific to that particular study that you want to solve. Then narrow down again. So there will be a research gap that you want to close. Okay, how should I give an example? Novelty is something that, first of all, that never have been done before. It must be something that never have been done before or never have been published before. Okay, so if let's say your idea have been published, it's not novel. Okay, that's why it's important for you to keep updating your literature. Okay, and make sure that if you have let's say within your 2-year study, you have achieved something from your idea, you must publish it first. That's why people keep publishing, they are like a competition. Who can publish this first? So that idea will become theirs. Who first published this one? Then the idea is the novel one. Okay, that's why it's important for research student to publish. Okay, to publish especially if you are targeting the high impact journal, they always look for novelty. If there's no novelty in your research paper, they can read through your article, okay, just briefly, and reject without further review from the reviewer, because they said that there's no novelty, no new idea. So how do you know that your idea is new? So that's why you have to keep digging and compare. Okay, this researcher has reported like this, and this researcher has report something else. So what else that has not been covered or has not been published? So you have to know. You have to make a detailed literature review. I always ask my students to make a table. Okay, make a table in the literature review. A detailed comparison of different authors that have been doing the same study that you are doing. Okay, this author have done this using this method, using these materials, and what is the result from this paper? The second paper is doing this method and these materials and this result. So from this table, after you have listed probably like 20 papers that they are doing the same study like you are doing, then you can see what is it that missing, what is the missing part, or what is the missing thing that you have discovered. From there you can see the gap. That's why I said research gap, the gap that you are trying to close. Research gap is the novelty that we are looking for. Okay, so when you have a lot of idea, turn it into something that is visible, and as I said, it's you have planning, right? You have planning. So you have a plan. Okay, this is how you are going to do it. So first of all, you have to make it into something that you can see. First. If you have a lot of idea, but you don't write it down, you will be like, keep thinking everywhere. Your thought is here and there, but to do it scientifically, you can write down and make it into a table, so that you can compare. Okay, from previous studies, these people doing this, these people doing this, these people doing that. So what is it left for me to do, right? So that's how you can find the research gap or the novelty. Okay. The second one is how to
what a difference point about the novelty between the proposal research and also the novelty in the journal.
Okay.
Is that any difference?
Okay. Usually for your proposal or your thesis, you must have different objectives, right? Probably for PhD 3 objectives, for master 1 or 2 objectives, right? But the novelty usually you for a thesis is you don't have to have like a lot of novelty. You can have one major novelty that you have, and you divide it into different objectives to achieve this novelty that you are trying to get, or the research gap that you want to get to achieve. So you can split it into different objectives, okay, and different scopes. But for article, usually you have to make it split the journal articles into your objective. You can probably, for objective number 1, you can have one paper, journal article, with you. Of course, you have to, if you are aiming for the high impact journal, of course you need novelty for each of the objective. So that's why it's important for you to know how to write in a high impact journal. You have to know how to write, especially the introduction part, to highlight, okay, what is the importance or the novelty of your research in your journal article. Okay, but for thesis, the main part that you are showing the novelty is the problem statement, the research question. That is the part where you have to show your novelty in your thesis or your proposal. Okay, you have to, in the beginning of your thesis of this or dissertation or proposal, you have to show the novelty in the beginning of your introduction part or the problem statement with your research question. Okay, but for the journal article, you can split it into different objectives to publish. Probably you have 3 objectives, then you can have 3 journal articles, example. Yeah.
So, or maybe for the conclusion will be the novelty in the journal will be part of the result from our thesis also, Dr. Dayang. Yes. Great. So for the next questions, because we still have questions from the Ibu Harmini from the ITS also. The questions is, when we use experiment research and to decision that our result is true or precision, should we compare our result or our method with another method from previous study or journal?
Okay.
And if it should be compared, how many methods that we use to compare? Is there a minimum method? Thank you so much. That's questions.
Okay. So comparison, right?
Yes.
Usually for comparison, you can have a control. Control meaning that, for example, in our experiment, you are measuring what I can say, the what example I can tell you is that, example, if you want to study the effect of you want to formulate, for example, this is my area lah, food. You want to formulate a new beverage, drink, healthy beverage. Okay, so how do you compare? How do you know that this healthy beverage is the standard one? Okay, so that's why you have a control in which probably you have a commercial beverage that you can compare to. For this beverage, healthy beverage formulation, for example, you want to study the viscosity, you want to study the effect on the different composition of the drinks, okay, on the stability of this drink, for example. So you can use a commercial beverage to, for example, to compare your result. Or you can use, for example, if you, in your healthy beverage, you add a new, for example, you can use different types of orange. Okay, so you can have beverage without the orange as your control for a comparison, for a benchmark, so that you know that, okay, this drink without the orange, it has this stability, but without the orange as your control. But when you add orange to your formulation, the stability increase, for example. So increase compared to the control. So you have a control system there, okay? And control is also important, for example, if you have different composition or concentration, okay? The control that without anything that you add is the one that you can have a benchmark to compare. That is the control. But if you say that you want to control different methods and also different types of if your study is different, to study the effect of different methods, then you can compare different types of methods. But if your study is just to to study the effect of the factors using that particular methods, okay, you don't have to compare. That's why, because that's why you have to make a justification. Okay, you have to make a justification why you are choosing that method. Why why don't you? Because sometimes for my study, we have extraction, right? We have different types of extraction methods. Okay, they are Soclet extraction, they are supercritical extraction, they are ultrasound extraction. But then why are you choosing ultrasound extraction, not the other types of extraction? Okay, so you can have a justification why you are choosing this. Okay, this type of method. But if you don't know how to choose, you don't know what to choose from the three methods, yeah, you can make a preliminary study. You can make a preliminary study, but of course, if there are 10 methods, you cannot do like 10 methods to compare, right? They are too much. Okay, that's why it's important to do the literature review. Literature review is important. Okay, limit how to limit your scope of study. You cannot just do everything, right? In your study, but actually from your literature review, okay, that's why it is important to make that table that I said. Okay, from the different types of methods, then you narrow down. Okay, these two or three methods are the one that are very common. Okay, they are used. Okay, and also these three methods are producing good results. Okay, what are the advantage and disadvantage of these methods? Okay, you have to list down in a table for comparison in your literature. Yeah, in your literature before you start your experiment. Yeah, before you choose which one is the method that you are using, you can list down these advantages and disadvantages, pro and cons of these methods before you choose. Okay, this method is having this advantage, and this method has this advantage, but this method has this disadvantage, which I think that I will not choose this method. Yeah, so that's why it's important in your literature that you do this first before you do your experiment. Yeah, if you have done this, you can justify why you are doing this, and your problem statement also relate to this, then you can choose one method with strong justification. But if you cannot do justification, you have to make like a preliminary study to compare the different methods, 2 or 3 methods, then you choose one, something like that. Yeah.
Thank you so much, Ibu. So there are a lot of things that we can do to make sure that our research result will be true or precision. Okay, I think for the next questions, because maybe we still have 3 minutes or 5 minutes more. From Bapak Priyo Adi Ramadhani from ITS also, is it necessary to discuss with colleagues, I mean, about the research plans that we will do? Is it normal? Yes, the research plan. So is it necessary to discuss with other colleagues or some or other people to about the research plans? So is it normal to have concerns that the ideas we have are stolen by our discussion partner? I think it is a lot of things that we can talk about this one. This is the concern, I think, for all of the researchers. What are your suggestions for this kind of questions?
Usually for research students, of course, you cannot stay by yourself alone. You'll be so stressful. It's a research
Yes.
journey is very stressful. Yeah, we understand. That's why sometimes you need your colleagues for discussion, right?
Yes.
But
Something like curhat
yeah.
in Indonesia means.
Yeah, but usually I think it's better for you to discuss with your supervisor as well. Yeah, because yeah, we cannot control, but we cannot control people intention. Sometimes you think that when you curhat with your friends, you just want to share without any intention or without any purpose to solve pun kan. Sometimes you just want to share, we just want to relieve our stress. But we never know people who has other intention, bad intention to us. We never know. So I think it's better to discuss with your supervisor. But if your friends or colleagues have a different background, it's fine lah. But if in the same lab or probably the same research topic with you, probably it's quite. It depends as well. It depends also. I cannot say that all people are the same. I cannot say because I have not reached to this kind of thing, but it happens. It happens. Yeah? I can say it happens sometimes when you share, or even within the other groups as well. Not only the research students, but also other researchers also happens. Other people stealing other people's idea. It happens anywhere. Yeah? Not only during your PhD, but also during your career later on. So that's why sometimes you must be very careful, okay? And especially when you're doing PhD, discuss with your supervisor, especially on the novelty part, okay?
Okay. I think that's because we cannot control people.
Yes.
That's the most important thing that we want to talk or discuss about our research plan or our research idea. And then I think for the committee, I think the time is already over for the Q&A session also. Okay, thank you so much to Dr. Dayang before I'm going to the MC. So today we have a very special talk about what is the important thing. The key point in our research is about the methodology, and we have a lot of things to do to make sure that our idea is genuine, is that's a real, have a kind of novelty, and something like we want to talk is like stealing the other idea that is our yes, because it happened. We cannot say it cannot happen, but it's happened. Not only for close friend is we don't know, because we don't know others willing people. So thank you so much to Dr. Dayang for this such a nice presentation, nice lecture. Also in here, it's for me it will be an honor to meet you, and for the committee, thank you so much. I think for the next collaboration within UTI, maybe we can continue for the like students research collaboration, or between the researchers also. And don't forget, after pandemic is over, maybe we can go to the UTM.
Yes, you're very welcome.
Yes, because I think from the photo we can see the beautiful scenery in there. I'm really okay with the green one. Very beautiful. So I think the committee also will be agree if we can go to there, and you going to the ITS as well. Thank you so much for the Dr. Dayang. And I think for the times, I will go back to the committee and from the MC. Thank you so much. And maybe apologize if I'm, as a moderator, have a lot of mistake during this conversation also. Thank you, Ibu Doctor, and thank you, committee from the MC.
Okay, thank you very much. Thank you very much, Dr. Dayang Nurul Fairuz, for the inspiring lecture today. And thank you, Ms. Iska, for conducting this amazing session. Please give applause for our inspiring speaker and also amazing moderator by using the Zoom action feature for today's empowering session. As a token of appreciation, I would like to present a certificate for our honorable speaker and moderator. So, Dr. Dayang, this is the certificate for you as our gratitude for today's session. Thank you very much for your availability today in providing the lecture session on common research methodology on your field.
Thank you very much.
Thank you.
Thank you, everyone.
Thank you, Ibu. Terima kasih, Ibu.
All the best in your study.
Thank you, Ibu.
For the next certificate, will be presented for our moderator, Miss Iska Desmawati, for being our moderator today. Thank you very much for your availability today in conducting the amazing session.
Thank you so much, Ibu. Thank you so much, everyone.
Thank you. And then before we part, I would like to inform you about our future events. One of it is International Postgraduate Student Conference 2021, striving for a successful postgraduate research. It will be on 11 until 13 November 2021. So this is a collaboration with Asahil. You can see this program you can see this information at ITS International Office Facebook and also Instagram. Next, we will have also socializing mobility program with scholarship, especially about ISMA, Erasmus Plus, SEED scholarship, and etc. And it will be conducted on Monday, 25th October 2021 at 3:30 until 5 p.m. And you can also streaming it through the YouTube of Global Engagement Office. And also, I would like to inform you that we will still have future agenda on RESET for hard engineering stream, which will be conducted on 4th November 2021. And it will be about research management skill, will be presented by Professor Rosalina Abdul Salam from University Saint Islam Malaysia. You can see the poster we are showing you right now, and you can check it on ITS Global Engagement website as well. So before we end the session today, I would like to invite all participants to open their camera to take a group photo before we part. So come on, everyone. So your best smile.
Okay, best smile. Don't be shy.
Best smile. And I will take a countdown so we can take a picture together. So there will be 8 slides. So please be patient with me. Okay. Are you ready? Okay, good. 1, 2, 3, smile. Another one. 1, 2, 3, smile. Okay, next one. Next slide. 1, 2, 3, smile. Next one. Third slide. 1, 2, 3, smile. This is the best one, the best group that I have because there are a lot of people here and they show all their camera. Okay, one,
great.
Smile. Okay. Number 5. 3, 2, 1. Smile. Next one, number 7. No, number 6 first. Sorry. 1, 2, 3, smile. Okay. Now number 7. Okay. 1, 2, 3, smile. Okay. So I think it's only about 7. So thank you, everyone. Now that we have finished the group photo, I would like to remind you all to fill the feedback form provided in the Zoom chat room. The participant who will get stamp for it, it is the participant who comes on time during this event until the end and also fill the feedback form. Finally, we have reached to the end of today's recep, and we sincerely apologize for any inconvenience during the session from me as the Master of Ceremony and from the committee as well. We will see you again on the upcoming session. Once again, thank you for everyone for joining the session. Thank you for the speaker and also for the moderator for the inspiring session. Good evening, stay safe and healthy. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you.
Bye-bye.
Thank you, everyone.
Thank you, Bapak Ibu.